Hey guys, my name's Sam Cheney and we're back with another Inspection Insights episode covering our favorite quality control software, GeoMagic ControlX. Last week we covered the automation server as well as batch processing and how to generally inspect multiple parts after you've set up an inspection report. I think that was pretty interesting. This week we're going to make it a little bit different. We're actually just going to get back to our regular routine and cover a specific industry segment. And this week we are looking at the automotive segment, specifically inspecting a crankshaft. Now, I am no expert on inspecting crankshafts, but I do have an idea of where they go in the vehicle and the demands that are put on this component. It needs to be very, very hard and goes through quite a lot of rigorous testing. And as part of that, one of them is going to be the dimensional inspection. Now we're going to cover everything from setting up the alignment to actually creating the inspection report, and I'll show you a few tips along the way as I get into this. For those of you who have been tuning into the Inspection Insights series from the beginning, you'll be very familiar with this. If you're new to the entire series, well, welcome. This is how a typical inspection workflow flows through ControlX. We start with our CAD data. This can be from SolidWorks, Creo, Inventor, wherever you get your CAD from, or it can be a neutral format like a step file or an IGES. And then we have our scan data, which is either acquired and scanned directly into ControlX, or it's scanned in a third-party software or sent to you from somewhere else and then imported as an STL file. Either way you get your scan data is completely fine. You can either use the live capture or the importing tool, whichever you prefer. We then align the models, and in this crankshaft I'm going to not do a best fit like I have been doing in other ones. I'm going to do something like a datum alignment, because when the crankshaft is actually in the engine, it's constrained very, very rigorously, and a best fit just wouldn't simulate the real world working conditions that it would actually be constrained in. Once it's aligned, we will do our inspection from the first dimension to getting everything ready for the report. If we had multiple crankshafts that we needed to inspect, we'd then do something like an automated inspection workflow where we've already created this inspection routine. We just then replace the scan data and refresh the dimensions and then get another report. We have three different packages when it comes to GeoMagic ControlX. We have Essentials for those just looking to start their inspection journey. It's cheap, cheerful, and pretty decent at doing basic to medium complexity level projects. You can import, align, extract, do whatever. It does have all the GD&T. The big thing with Essentials is you don't get the ability to scan directly into the software, so you don't have the direct scanner plugins or the tools for portable metrology devices, which are like arms and things like that. We also can't do multiple inspection results in the same window. Surface defect and aerofoil are all tools that are only available in DesignX ControlX Pro. If you are interested in reverse engineering, though, there is a software that we also sell called GeoMagic DesignX. We have a similar level of webinars called the RE Lab, run by Greg George. It happens every Wednesday, so if that's something that you're interested in, be sure to either sign up for that or go over to our YouTube channel and check out the RE Lab as well. Anyway, that's my little plug for that. Let's get over to ControlX and have a look at what we're doing today. Here we are. This is GeoMagic ControlX. I've already kind of been through some of the basics, so if you'd like to learn where everything is and all of that, be sure to scroll back and go to one of my beginning Inspection Insights videos. But today we've already got our model imported over. We also have our measured data, which is here. And just a quick look at it, it looks pretty good. There is some areas that we didn't be able to get, like this area over here. That's very difficult to get just due to the line of sight. The fact that we even managed to get it over here at all was probably pretty good. We also have some holes over here, which are on some of the CAD model, but you can see we're missing a hole here where there should be one. So that's the first thing that my eye is drawn to. Is kind of like a spot the difference. To make this spot the difference a little easier, we can actually do something like a comparison, but I'm getting ahead of myself. The first thing we need to do is, it looks aligned, but we don't have any alignments over here. So we're going to do an alignment. The first thing we're going to do is an initial alignment. There we go. Now we need to do a more, formal alignment that's going to be the alignment that we use for the rest of the inspection. I'm going to use the datum alignment, and this is where I pick my datum pairs. So, maybe I want to pick this this cylinder or cone here because it's drafted as my first one, and you can see that controls the X and the Y, the Y and the Z axis and rotation, but we still can move the part in X and rotate it about X if we want to. So we need another pair. Well, I'm going to grab this face here. Okay, so now we just constrained the the X-axis movement, but we can still rotate this model about the X-axis. The final construction point I will do is probably going to be, a plane here. I could do one of these holes, but again, if we look at what the scan data has, being able to get into this cylinder isn't very accurate, but we do have a really nice set of flat data over here, so we can use that. But again, it's up to you. If you have datums already called out on your drawing, you can use those. I'm obviously doing this inspection without a drawing, so I'm just kind of making it up as if I were trying to match some theoretical drawing. But once I've got that, I hit my check mark, and then I will have aligned the CAD or the scan data to the CAD data. All right, so again, talking about that spot the difference, if I wanted to make it easy for myself, I could turn on my 3D comparison. I don't need to use selected data only. Hit next, and you're going to see the the inspection, or at least the comparison. So you can see it's pretty good. We've got, it looks like we're maybe missing draft angles on these faces here. Maybe the CAD is, flat and the mesh is rounded, or maybe this mesh is actually, worn out, or maybe our tolerances are, too tight. If we wanted to, we can adjust them. And if, again, I've already covered this tool in detail, so I'm just going to kind of leave it at that in terms of, what I'm going to show. Okay, so we have our part aligned. We can then start our actual inspection. So the first thing I'm going to do is come to my Dimension tab, and I'm going to create some datums that match the datums that I've already created. So I'll grab this one, I'll grab this one, and I'll grab this plane here. Just want to make sure it's nice and straight. There we go. If I wanted to add any more, I'm more than welcome to. Nobody's going to stop me. Maybe I want to add one for this cone here. We'll do one over here, and I think that should do us. There we go. So we've got our first group with datums A through E. You already know what I'm doing now. Changing this. I'm going to give it a nice name, so when I'm looking at this report later, it's very easy for me to identify which group is what. Okay, so we've got our datum group. Turn that off. Now I can add another group, and in this case I'm going to start taking just length dimensions along this, and there's a few different ways I can do this. I could do a linear dimension, and then select this one, and I don't know, this side to maybe this side, move it up, give it a tolerance if I'd like. Let's do 0.01. There we go. And you can see it's out of dimension, out of tolerance. 0.0934 out of tolerance. Now, if I wanted to go along all of these and I had, either continuous dimensions or baseline dimensions, I can do that too. So I can actually delete this. And what I can do is come to my linear dimension, and instead of an individual, I'm going to say, hey, I'm going to do a baseline. And my first baseline is going to be this one. And then I can grab, whatever face I'd like. So maybe I want to do this one again. Come up, grab it here. And then all I have to do is click on the next face. And then you can see there, I get another dimension. And we want to come back here, come up again, another dimension. Grab this surface here. Oops, I don't want to grab that line. I want to grab this plane here. There we go, much better. Move it up. Oops. Oh, I'm making a real pig's ear of this. There we go. All right. Grab plane, grab plane. There we go. Much better. So if you mess up and you've got to do it again, you hit escape or something like that, you are going to have to click the original face just again if you'd like. And you can see this is all, this inspection is very, very red, very out of tolerance. But that is because we have no tolerance. It's all saying 0, 0, 0. So of course we're not going to have, nothing's going to pass if we set the tolerance to essentially like failure, which is fine. We're going to come back and edit all of the tolerances in a second. So there we go. Let's do my last one. Let's do this end section here. There we go. And there. Okay. So we've got all of our dimensions stacked like this. I can move them around if I'd like to. Maybe spread them out just a little bit more. Okay, that's looking good. But obviously everything's red. How do we want to edit all of these tolerances? Well, if there's just one or two, you can double click on each individual dimension, give it a tolerance of 0.01, hit enter, call it good, right? Or if you wanted to edit all of them at once, click and you hold shift to select all of them, and then you can come into the tolerance here and specify that, and there you go. We've added tolerances to all of them. Now obviously this trick only works if they all have the same tolerance. If they all have different ones, you'd have to individually click on them and edit them. But I thought that was a pretty useful tip in case you ever have to change the tolerances of multiple. You just hold shift, come all the way down, and then instead of trying to click on any of this or come in and edit them, you just change the tolerance in the properties. So there we go. All right, I'm happy with that. Now I can start adding some GD&T. So let me turn my datum group back on, and I'm going to add another group. And before I do that, let me just rename there we go, dimensions. All right. And if you're ever if you're getting confused with which group you're working in, if I do a datum now, or sorry, datum, if I do a dimension now, or I add some GD&T, which bucket is it going to go into? Well, it'll probably go into whatever group you created last. But if you want to know which one you're actively working in, you can come to select group, and if I wanted to go back to my datums and add another datum, that is entirely up to you. You can do that just fine. Okay, so now I'm going to go back, edit my group 2, and start adding some dimensions. Probably a good one that we want to look at is probably going to be the the concentricity. If we can grab this one, target this face, and do we have any that are down here? No, we don't have any, so I'm going to discard concentricity. Let's grab this one, and we're going to constrain it to our datum, which is going to be datum D. Grab this one as well, same thing, datum D. If we wanted to, another fun one. This is a bit of a tricky one because we don't have a ton of scan data in this section. But if we wanted to take, a radial dimension of, this cylinder, we can. We'll just come in and specify our tolerance, 25.4. Why not? And then if we want to grab the rest of these, well, instead of again clicking on all of them and creating them, we can just come to this pattern, and it's going to search for as many as it can. It didn't get this top one, and again, that isn't necessarily ControlX's fault. There's just a big old hole here, and then this section here there's a lot of missing data. So, but there we go. And instead of having instead of taking 6 individual ones, we can take 6 just like that. There we go. So let's turn this one off for now and get back to our GD&T. If we want to do any more, we can do maybe the flatness on this surface here if it's critical. Let's say 1 millimeter. There we go. If we wanted to do some true position callouts for maybe these cylinders here, specify our a datum structure, AC, and there we go. And yeah, I mean, I could go on and dimension this until the cows come home, but this, hopefully you have learned a little bit from this. Like I said, the big tips for today was editing multiple dimensions, and then setting up datums and editing which groups you're working in. When you're happy with it, we always go to our home, generate report, and we'll see a preview. I can hide my initial alignment and our 3D compare, and I can hit generate and give it a second and move it over to this screen, and you can see we've got our inspection right here. The last thing I want to show you, we can always come back and edit this screenshot if we'd like. Last thing I want to show you, in case you didn't know, if you ever want to change the color of the mesh that you're working in, if say you didn't like this blue, you can come to this material here, click on this arrow, and then you can change it to whatever color you want. And not only can you edit the color, you can actually also give it some transparency or change the shininess. So if I wanted it to be a little bit more see-through, you can change that. And why would you do this? Well, if you want to display the CAD and the mesh on the same section, and you want to see these lines on the CAD, it's kind of hard to do when the mesh is at 100%, like opaqueness. It kind of gets in the way. So I like to, if I'm having to do screenshots or I'm having to visually show both of them at the same time, I like to just change the transparency some, just so you can subtly see that there's a mesh hiding underneath it. So yeah, hopefully you learned something. Feel free to comment with your feedback. I would love to learn what you guys want to see next. And yeah, I hope you have a good day and see you on the next Inspection Insights. Bye.